Hello and welcome to the Consistency Project Podcast. My name is Patrick Cummings. I'm here as always with E.C. Sinkowski. Every week on the show, we aim to simplify the principles and practices of nutrition, health, and fitness. Thank you for tuning into the show. Hello, E.C. How are you?
Great. How are you?
Lovely. This week is we're going to explore whether all protein is created equal. We're going to examine if animal protein specifically truly offers superior quality compared to other protein sources. Back on the protein train, EC.
We can't get off.
We can't get off. Before we jump in, though, a quick mention. Gym owners, if you're interested in bringing the 800-gram challenge to your members, head to optimizemenutrition.com/gyms. Sign up to be notified when the first gym challenge launches for the new year. You know how important nutrition is to your members' progress, and you also know how hard it is to get them to take consistent action in the right direction. Skip reinventing the wheel. Join our next gym challenge at optimizemenutrition.com/gyms and give your members the smartest, simplest path to better nutrition than they've ever experienced before. Alrighty, see, let's do a quick bit of background on why we are talking about protein, and specifically animal protein this time around.
Yeah, I do think it's pretty widely accepted on the internet anyway that, this idea that animal protein is always better. And in combination kind of with some studies that I look at weekly about the new research that's coming out that I've kind of seen, as well as like stuff that I see on the internet. For example, Dr. Mark Hyman, who, yes, a well-known MD doctor, but he focuses on functional medicine. He's got a huge following. He has some really wacky nutrition advice, but he had a recent post as well that's kind of like animal protein is always better. So I think it kind of just was like, yeah, let's actually address this is animal protein better, especially for building muscle, which of course our audience is always interested in.
Yes, of course. Okay, so we're going to use that Instagram post kind of as a launching pad for some of these ideas. Yes?
Let's do it.
All right. So I believe we've got three claims inside of a short Instagram post. You did a good job there. Three different claims that we're going to look at. The first one, and I'm quoting here, not all protein is created equal. When it comes to building muscle, animal protein is more bioavailable, more complete, and more effective at stimulating muscle protein synthesis than plant protein. So let's maybe respond to that one first.
Yeah, these are super common concerns, some of which we've talked about before. But, as I keep trying to let people know that so long as you're getting enough total protein, you really don't need to focus on the different types of protein like animal and plant-based. Now, we got to go through each of these three different claims within this first claim. And the first one is that complete idea.
Yep.
And this, of course, refers to whether or not you're getting enough of the essential amino acids. So again, amino acids are these building blocks of protein. They're kind of like Legos that fit together, if you will, to make these bigger protein molecules. And there are 20 amino acids. But 9 of those 20 amino acids we must obtain from the diet, and that's why they're called essential. Now, animal proteins are considered complete because they contain all 9, but here's the part that people often don't hear or forget about. They contain all 9 in the proper quantities that support growth and development. And why do I stress that? Because plant proteins do also contain all 9 of the essential amino acids. It's not like they're missing any of them. It's just that plant proteins tend to be more variable across those 9. So if you were to only eat beans, your favorite diet's just straight black beans, Patrick. If you were only to eat black beans, for example, you'd be really low in the essential amino acid methionine. Or if you were only eat grains, you'd be too low in the essential amino acid lysine. Where animal proteins, they have a better representation, even just one of them, across all of those essential amino acids compared to any plant protein. Now, of course, we're talking about nutrition. There's going to be some exceptions. It turns out, for example, collagen is an animal protein, but it's totally missing the amino acid tryptophan. And then soy is a plant protein, and it's pretty darn comparable to some of our animal proteins. But nevertheless, we generally see kind of this trend. But it kind of already starts to prove this point of me going into those exceptions that I think we start to obsess about these things like animal protein is always better, when in the reality is when you start to look across the fact that somebody's going to eat more than one food source a day to get their protein needs, they're going to get enough of the essential amino acids, even though it might not perfectly come from one source. And especially when we're looking at us in an industrialized country, like nobody listening to this podcast is getting all of their protein from black beans or from wheat bread. So it's just another great example of how, one of my principles focuses on the total macronutrients you consume. It already covers this concern about whether or not my protein is more animal-based or plant-based. The second comment he made, the bioavailable comment, we actually addressed this in a kind of recent Quick Bites episode. We'll link it in the show notes. But when we look at the digestibility of common plant proteins like soy protein or even just tofu, it's really not that far off the digestibility of beef or chicken. And to be honest, if the digestibility, and that's really what the bioavailability is getting after, that the amino acids, when we break them down in our GI tract, we might not be able to access all of those amino acids because these plant proteins might not be, quote, as digestible. But, if digestibility was the big limiting factor, what we would see is that vegans would need way more protein to build muscle because they wouldn't be accessing those amino acids in their plant proteins. But the evidence doesn't suggest that is true, and we're going to actually get to that with another one of Mark's claims. Now, finally, the other comment he worked into this one was that muscle protein synthesis comment, and Dr. Hyman is incorrect yet again. What we find with muscle protein synthesis, or MPS, on vegan diets is that they're not different from animal diets. And we talked about this in a recent Quick Bites episode because we had somebody send in a paper. It's this ASCOW paper in the show notes. And then I also dug around a little bit more to find more than just one study. We've got the Montaigne paper in the show notes as well. Both of them, of course, are human randomized controlled trials with humans, and they found that these muscle protein synthesis rates, or the MPS rates, were not different between the vegan or omnivore group. Which, by the way, looking at the MPS rates really isn't the right question to be asking, because again, we're not just interested in did the body start the building process? That's the MPS rates, that's the muscle protein synthesis rates. We're not just interested in that. We want to know, did that building process actually result in more muscle mass overall? And of course, we're going to get to that. But this is just another example of where something so simple as looking at the appropriate total quantity of protein in the day is good enough, and that these recommendations that might seem basic are actually far-reaching, and you don't really have to worry, or you don't have to worry, what's my animal versus plant-based split when you're getting enough total protein.
Got it. Okay. Second claim. Animal protein is, quote, also richer in key nutrients like B12, iron, zinc, choline, carnitine, creatine, taurine, and retinol, many of which are lacking or poorly absorbed in plant-based diets.
Yeah, we're not going to go through all of those because I don't think we need to. I will circle back to especially B12 for vegans, but for the most part, we find that these nutrients are already readily available in plant foods. That would include things like iron, zinc, choline, vitamin A, and or they're just not essential like carnitine, creatine, and taurine, and they can be made from other nutrients. And so I just don't think that we need to focus on these nutrients individually. And I want to highlight iron as an example out of these because I think iron is one of these ones where people would be surprised to learn that vegans on average are not at risk for deficiency. Meat is very well known as a very good source of iron, and it is. And so that's why I think, people would be surprised to learn that the studies don't show that vegans are deficient on that on average. There are different forms of iron. Heme iron is what we find in animal sources, which tends to be more readily absorbed. And then there's non-heme iron, which is in plant sources, which isn't as well absorbed. And so this further adds fodder to the kind of, basic belief that, quote, animal protein is always better, especially if you want to get something like iron. But this is where we can focus on things that are like potential mechanisms of, okay, well, what's the absorption? What's the type of iron and how well it is absorbed? Or we can look at what's actually happening with like real free living humans eating their diet and look at their outcomes. And so that's that Lopez Moreno study in the show notes. And that's where we can look across multiple different populations and see that vegans and vegetarians on average are not lower in iron than omnivores. And so then we have to kind of back out of that and think, okay, well, how can that be? And one, beans, veggies, nuts, and seeds, these can all be sources of iron, even if it's the non-heme iron type. And the body is incredibly intelligent that when somebody has lower iron stores in the body, it will increase the absorption of the iron in the GI tract. And so this is where somebody who might be eating more non-heme iron isn't necessarily going to be more deficient. The body just increases the ability to absorb that iron. What's also sort of ironic here is that heme iron in the animal-based protein could be the driver for the more consistent increase in the risk in colon cancer that we see with red meat. Now, I want to be clear, I eat red meat. I think there's a safe dose of red meat in the mixed diets, of course, with lots of plant foods. We've talked about that in a podcast that we'll link in the show notes. But specifically, he's saying, okay, iron is the problem for plant-based eaters, or iron is one of the problems for plant-based eaters, and it's not. And it's even a potential drawback for people eating meat. And so not only are our plant-based eaters not typically deficient in it, but they might be better off from a colon cancer risk. Now, I do want to come back to vitamin B12. This is a good exception to call out, especially for vegans, because vitamin B12 is in animal foods to include dairy and eggs. And so people who are vegan could be lacking this nutrient. But vegan sources have been fortified. The common ones are like nutritional yeast or some of our plant-based milks, such that people who are eating vegan can still be fine in this nutrient if they're not just going to also potentially supplement with it. And this is where some people will say, oh my gosh, well, you have to maybe supplement with vitamin B12 or use these fortified foods to get your correct vitamin dosage. See, an animal-based diet is better. And it's just like it's a very limited view of things. If vegans achieve nutritional adequacy by having a fortified food or having a supplement, and then they're able to hit all of the other nutrients by a diverse whole food based diet, they are not worse off than somebody who's doing the same thing with animal foods. There's sort of this, again, that underlying belief that natural is always better. And it's like, no, we have to look at the outcome to decide that. I guess if somebody was in a really limited environment and they had only animal foods to pick from, then yes, we'd want that for the vitamin B12, but we have to expand out to the reality of where we exist and look at what our foods are available and what kind of nutrients that we can achieve. So my point here is not to try to convince people to be vegan. I'm not, although I certainly support eating more plant foods for most people. The point here is there's so much stuff on the internet that starts making you think you need to focus on details that do not matter, when those details have already been addressed by broader, more comprehensive nutritional guidelines. Like, you do not need to independently worry about zinc or iron or choline if you're doing a mostly whole food diet in the proper quantities.
Got it. All right. The third claim. This is a little bit of a longer quote, but I'll get through it. Yes, you can build muscle with plant protein, but you'll need significantly more of it, or you'll have to supplement with isolated amino acids like leucine. This means more calories, more carbs, and less nutrient density. And while some plant proteins like soy or rice concentrate can be fortified with leucine, it's often not enough to properly trigger mTOR, the pathway that drives muscle growth, particularly as we age. If your goal is to maintain or build muscle, especially as you age, quality matters more than quantity. End quote.
Another strike for Dr. Hyman. Yeah, another great example of, we're talking about all these details and mechanisms. Oh, do you have the amino acid leucine? Or we're going to talk about the mTOR pathway, which basically the mTOR pathway stimulates muscle protein synthesis, or MPS, as we've described before. But this is, again, we don't have to argue about leucine. We don't have to worry about mTOR. We can actually just check in with the literature to what happens to people's muscle mass on animal or vegan protein-based diets. And drumroll, total quantity is more important than quality. So there's a Reed McCann paper in the show notes. This is a meta-analysis this year, and they pulled together the results from 30 randomized controlled trials comparing plant versus animal protein, and they looked at the effect on muscle mass, strength, and performance. And of course, those things are not one and the same, although people often think they are. But nevertheless, there was no significant difference between plant and animal protein for strength or performance. And then animal protein had a small beneficial effect over non-soy plant proteins, like if the people were eating oat, rice, or potato. So it wasn't even better if they included soy, but it was better if the plant protein was more oat, rice, or potato. So you could say, oh, okay, see, this is evidence that animal-based is better. Not so fast, not so fast. When you go down into the studies that they pulled together for this, most of the studies they pulled together, they didn't actually report the total quantity of protein that people were eating each day, which is not good. Of course, people listening to this podcast are like, yes, we've heard you say it before, total quantity matters. So when they were looking at, okay, is this person eating plant protein or animal protein, they didn't necessarily know if the person was, let's say, doing 0.5 grams per pound or 0.7 grams per pound, which of course is going to be very important. So even without that knowledge, there's still evidence right there that soy-based plant protein is performing just as well as animal-based protein. In addition to that, we have more studies, such as the Montan paper that I cited earlier. They were looking at vegan and omnivore protein intakes And not only was NPS not different, as we already mentioned, but muscle mass and strength gains between the two groups were basically the same. And they were measuring their protein intake, and that was at 0.8 grams per pound, so slightly higher than what I typically recommend. But then we have another paper, the Lorraine paper in the show notes, and this was super interesting because they didn't just give people like a 12-week study of giving them soy protein. They actually found habitual vegans, so people that were truly vegan and had been living that way for some time, and then they compared them to omnivores. And guess what? They were at the 0.7 grams per pound level that I recommend. And the gains, muscle mass gains, strength gains between vegan and omnivore groups with resistance training was the same. So we have multiple lines of evidence to suggest that quantity, total amount of protein, is more important, like reach that 0.7 grams per pound for your muscle mass, for your strength, for your performance, than worrying about, animal versus plant-based, and certainly than worrying about what your leucine content is or whether or not you're activating the mTOR pathway.
I've lost so much sleep worrying about my mTOR pathway.
I know, the mTOR pathway. Oh gosh, how am I going to sleep tonight?
As it relates to this animal versus plant protein, what questions do you still have? Where do you feel like maybe the research is still lacking or lagging? And what would you, we've talked about before, like whether, like when you come across these things, how often do they confirm what you already believe, not in the confirmation bias kind of way, but in
Sure.
That's one more checkbox on the argument that I've been making. Like, what would you want to see to either change your mind or further solidify that your general perspective that you lay out in the 3 pillars method is still the one you recommend?
Yeah, I'm glad you mentioned that about the confirmation bias. I mean, I'm going to be perfectly honest. When I first kind of started with nutrition, I believed animal protein was better. So I'm glad that I was open enough to be willing to look at evidence like this and be like, oh, wow, yeah, like animal protein is not clearly better. And in fact, probably has more risks, especially by way of saturated fat and potentially the iron, as we discussed. So anyway, I think, first of all, we can always use more research and everything. So many of these studies are shorter than we would like. They're smaller than we would like. And so even though I think we have a good amount of evidence to suggest that type doesn't matter relative to getting enough, we can always use more because it just gives us more evidence that what we believe is true. But I do think something is interesting that he said. It was kind of slipped in there at sort of the end of his third claim. He was talking about, especially as we get older, quality is more important than quantity. And I don't think we have the evidence for that at all. But I do think where we have room for definitely more research is teasing out what is going to be an optimal level of protein as we age. I know we've talked about it before on the podcast. I certainly think that higher than the RDA is going to be more optimal as we age. So the RDA is close to 0.4 grams per pound. The research suggests 0.55 grams per pound is better to prevent against sarcopenia. Now, of course, people at my 0.7 grams per pound are already there. So I do think we need more than the RDA as we age to be optimal. But I do think that there's room in the literature to determine, is 0.55 grams per pound optimal? Should it be higher? And there really isn't a lot of research done with older populations anywhere near 0.7 grams per pound that I recommend. A lot of times when we look at, quote, older populations, the high protein intake is 0.55 grams per pound. And I think there's a lot of different reasons for this. Typically, as people age, they eat less. Some of it is dysphagia. Actually, that becomes common as people get older. That's difficulty swallowing. People tend to also lose like taste and smell, so food isn't as appealing. So I think getting people upwards of 0.7 grams per pound would certainly be hard in that population, but it's a place where we could for sure use more data and to see what's truly optimal as people age.
Yeah, interesting. I've had multiple conversations with my parents about upping their protein.
Yeah. And, real quick on that, I mean, we have to be honest, and we look historically, like the idea that all of our ancestors were doing 0.7 grams per pound is just totally preposterous when, if you look around and you see that's like not what people are naturally eating. I do believe it's more important for people to stay active as they get older because that's going to be more of the driver than necessarily the eating of the protein. So I don't think necessarily that everybody needs to be at 0.7 grams per pound. But again, in our quest for optimum and what's kind of best practices, we certainly need more research on that.
Yeah, got it. Big takeaways maybe for you in having dived back into the research as you did just to kind of prep for this? And then what are the big takeaways do you think for me, for those folks out there listening? What do we do with this?
Yeah, I know we've talked about, some of these principles, these 10 principles of nutrition that I've come up with before. And I really do think they're certainly not perfect, but I really do think they help people kind of navigate the nutrition landscape better than just sort of remembering these, random facts about, amino acids or whatever, choline, mTOR pathways and all of that stuff. And so just to highlight some of the principles represented here, it turns out that getting the total macronutrients right in your diet, that's really principle 2, such as your total protein grams, is really going to be the important driver for body composition, muscle mass, etc., not necessarily, again, whether or not it's animal or plant-based. And then also the quality of your diet is important. This is really principle 4, that we need to make sure we have things like iron and zinc. Yet there's a power in whole foods that when you have a diversity across a good base of them, you don't independently have to worry about any single one, especially in a mixed omnivore diet. Like, you're going to be adequately covering yourself across those, even though you might not be measuring zinc today. Mm-hmm. And so this is where like the basics are just not so basic. These basic truths have a lot of evidence behind them that, maybe I don't explain bioavailability every day or MPS every day or mTOR every day or leucine every day, but it turns out that guess what? When you hit the total protein that you need, you're addressing those concerns. And so this is why something like my 3 pillars method, where you do focus on total protein, is what to focus on. Now, I will say, to Dr. Hyman's credit, towards the end of the post, he does start to say, okay, really got to focus on getting 0.7 to 1 grams per pound of your total protein, no matter what you eat, which is great. But the whole lead into that was 3 claims about, are you getting enough choline? And quality is better than quantity. So this is where something like this can send people down these kind of rabbit holes and think that focusing on something so simple as total protein, as I do in my 3 pillars method, is too simple, when in reality, it's actually more inclusive and more comprehensive.
Right on. All right, before we go, 2 quick reminders. First one, optimizemenutrition.com/gyms. If you are a gym owner and you want to bring the 800 gram challenge to your memberships, do go to that URL and sign up. And then 2, make sure you're subscribed to the show wherever you're tuning in so you do not miss another episode. EC and I will be back next week for a brand new episode of the Consistency Project podcast.